Hi Mustangs! I hope you're doing well at home. I sure do miss you. I also miss the library and the iLab. Have you wondered what's been happening to those items? Well, I want to let you in on a little secret. The 3D printer is actually here at home with me. A couple weeks ago, one of our fifth graders was inspired by our choice board to create his own STEAM activity, which was how to make your own mask at home. Over the weekend, it got me thinking, I have a 3D printer here at home. Could I make a mask using the 3D printer? Could this 3D printer be used to solve some other problems? Well, in conjunction with all of the librarians at D181 and the Hinsdale Public Library, we have put all of our printers to use to make the components for some shields for our healthcare workers. When they're finished, the shields look like this. The 3D printer is printing the top headpiece and also the bottom chin piece. And then the library, the public library, is putting together the plastic and sending those out to everyone who would need them, so that when they are worn, they completely cover the face of the person who's wearing them. In fact, my husband, who's a police officer, had another company that donated 30 of these to his police department. We want to keep as many people safe as possible. So let's take a look at what this looks like to print a face mask like this from beginning to end. What you're looking at now is the slicing software that we use to tell the 3D printer what we would like to print and how we would like it to be printed. When you are inside Tinkercad and you create something, the file that you save is called an STL. I cannot take an STL file and just upload it to the 3D printer. I first have to go into a slicing software, and the software that we use here at Monroe is called Dremel Digilab. So I've uploaded the headband. You can see here that it is on the print bed. It fits inside. I can move it, but now it won't let me print because it's off the print bed. So I have the ability to move things so I can get multiple prints on at once. If you follow me over here to the right-hand side, you can see that I get to choose what kind of qualities and settings I would like each item to be printed. And these can all change. The layer height is going to tell me how high each layer of filament will be. I have it set to 0.3 millimeters. That's about the width of a piece of hair. That's how tall every line will be. And that's how wide every line will be. The next thing I've set is the shell or the wall thickness. Think of this like an egg. I need the outside of this headband to be as thick as possible while still being able to move and bend with the person that is wearing it. So the ideal setting for this is exactly 1 millimeter. The top and the bottom, where it adheres to the plate here at the bottom, and the top is just slightly thinner at a 0.9 millimeter. Infill density is what it looks like inside. I don't want these headbands completely hollow. I also do not want them completely solid. It would take probably 24 hours to print one of these if it was completely solid. I have it set to about a 10% infill. I'll show you what that looks like on the printer in just a little bit. The infill line distance, so how far apart it is going to be 3 millimeters, and it's going to follow a zigzag pattern. You can do grid patterns, line patterns, all sorts of different choices based on the type of item that you are building. As I move down to the material, you'll see again here that the temperature is in Celsius. I would love to hear from you in your Google Classroom or Seesaw, or however you communicate with your classroom, what the conversion is for 220 degrees Celsius into Fahrenheit and 35 degrees Celsius into Fahrenheit. That is a great math conversion for you to work on. The printing temperature is going to be how hot the extruder is, or that's the fancy word for the nozzle, where all of the filament is melted and comes out. So that gets pretty hot. The build plate, which is this guy right here, that warms up as well, and that gets to be about 35 degrees Celsius. That helps the item stick to the build plate. And then we also have how much is coming out of the extruder. 1.75 millimeters at a time is coming out, and we want that flow at 100% or full speed. Now, what we do not want at full speed is how fast the extruder or the nozzle moves across the print bed. So I've slowed it down quite a bit. You can see here that it's being printed at 50 millimeters per second, which is quite a bit if you think about it. The wall is going to go a little bit slower because, again, as we talk about that egg shell, that shell of the item that we're building, we really want that to be sturdy and intact. It's traveling from one point to another point without letting any melted filament come out. That can go very fast. But what I need to be very slow is that first layer that's going to be put on the print bed. We want to make sure that it goes very slow and is cooled down so that it gets good bed adhesion. I'm going to show you what happens a little bit later when you don't have good bed adhesion. In fact, you've seen some things in Monroe's 3D printed graveyard that did not turn out so well. I do want things to cool off as it's printing. We have a fan that runs to make sure that the temperature stays at the correct temperature that it needs to. And I don't have any special rafts or support that are printed on it. Now, when I click prepare, what it's going to do is it's going to run through the slicing program. It's going to take all of these numbers and the information that I told it that I wanted, and it's going to start saving it to a new type of file. And it usually takes anywhere from 30 seconds all the way up to, I think 5 minutes is the longest it's taken. Now that the whole thing is sliced, we can have some additional information that we can look at. It will tell us the parameters right here in millimeters, again, in the metric system and not in our customary units, how long, wide, and tall it will be. It's going to take about 3 hours and 28 minutes to print, and it will even break it down for you how much time is going to be spent on which type of filling. And over here, it tells us I'm going to use 15 meters of filament or that they weigh 45 grams. So again, another great conversion if you want to put 15.29 millimeters into feet or 45 grams into ounces or pounds. That would be another great conversion for you to do. One of my favorite things to look at over here are the layers. I usually look at the layers at least once for every build. What layers let me see is the inside of the build and what it will look like every single line as it moves forward. The bottom is going to be yellow, and we can see that here, that it's adhered to the plate. And as I move up a couple of layers, I'm on layer 10, I can see the red is starting to fill in here, and that's the shell. I can get a good look here and tell that the shell is nice and thick how I wanted it, but not too thick. And as I move further up, this one's a little bit harder to see, but I can get in there and I can see the infill to make sure that it's filling in there in orange. And when I take you to the actual 3D printer, you'll get a good opportunity to see what the infill looks like. And I can see it continue to build line by line and make sure that it's set up and doing exactly what I wanted it to. And it looks good here. So now what I'm going to do is I am going to save it to a USB drive and then go ahead and plug that right into the printer. There are multiple ways to start a print on a 3D printer. You can upload your STL file from a USB drive, or you can have it directly downloaded to the actual hardware inside your 3D printer. I'm going to go ahead and use the USB option that I have here, and I have named this particular file Shield because that is the name of what we're going to be using. You can see here it's going to take about 3 hours and 27 minutes to build. The temperature for the nozzle where the filament comes out, which is the plastic that melts, is 220 degrees Celsius, and the platform temp needs to come to 35 degrees Celsius. To start it, I click Build. You can see here on the screen that we have some gauges that are showing us the progress of how the 3D printer is heating for both the nozzle temp and the platform temp. It looks like the platform is ready to go and we are just waiting on the nozzle to heat itself up. Again, this usually just takes a minute or two. And while we're waiting for this, you might wonder, what is all of that purple stuff on the print bed? That is actually glue. A regular old glue stick is used on the glass plate, and it helps that first layer of plastic really adhere so that we don't get some of those wonky things that we noticed before where it didn't adhere to the print bed, then the print itself was ruined. What's happening right now is the bed of the 3D printer is coming up to the nozzle, and it is calibrating to make sure that the bed itself is level. This will make sure that we end up with a really good print. Also make sure that nothing is uneven or falls apart. I'm sure you've seen some things in our library under the 3D printing graveyard that didn't turn out so well. In fact, if I peek a little closer down there, you can see some yellow chin straps that actually fell into the 3D printer. I did not realize they had fallen under there. So the calibration takes a minute or two as it tries to get the settings. And then what happens next is the bed itself heats up to those 30 degrees Celsius, and the nozzle where the filament comes out heats up to 220 degrees. Do you remember when we looked at the Dremel slicing program? We can actually set how thick or thin each of those individual lines goes down on the print bed. The smaller the line, the better quality of print you will end up with. And maybe smaller isn't accurate. Maybe the more accurate term is to say the thinner the line, the more precise the print will come out. Okay, we are about an hour into our build here, and I wanted to kind of zoom in and take a close look at what this is like if the machine will cooperate. You can see right here, those zigzag lines are the zigzag infill pattern that I mentioned before. That gives it a semi-solid state, making it just sturdy enough without making it a 100% solid fill. Look at that precision work on the 3D printer. That tiny little fill-in right there is where that thin piece of plastic is going to fit right in between, with that little nodule being able to hold that in. The 3D printer can really do quite a few amazing things. You can see that the face shield is really taking shape now. It's easy to identify which parts are what. We are building both the headband piece and the chin strap at the same time. Really close here, you can see that the nozzle is barely skimming the top of the headband. It's laying down one very thin layer at a time. And you can see here that it is going over the top edge. When we zoom in really, really closely here, you can see how each layer is put on and that they are essentially melted together. This set of headbands is finished, and now what I need to do is I actually need to use a little scraper tool, this guy right here, and go ahead and pry it off of the bed plate. Remember, we want really good adhesion, which means we really want it to stick so that we don't have the problem that I showed you earlier where the bottom didn't stick. So give me just a minute and I will take that off. Okay, you can see that this has come off. In fact, when I pull the pieces off to the side, you can see where it had adhered to the plate right there. And again, we use glue on the plate here to make it stick really, really well so that it doesn't pop off. Part of our iLab has been moved from Monroe School into my basement. You can see here that there are a number of different headbands that are completed. They're currently in bags of 5. Once they are finished wearing gloves, I take them off and I put them inside a bag to help keep them as clean as possible. And then let's take a look at a finished product and how it comes together. So the top here, you can see that we have a headband that is completely done. There is a very thick plastic that has been 3-hole punched so that it fits across the top here very snugly. And then we have an elastic band, in this case, a very thick rubber band that is used to go around the head. The edges have been cut nicely around here so that they are not super sharp. When you're wondering what this material here might be, I want you to think about a very thick transparency paper or report cover that has exactly the consistency and the thickness that we need to make sure that this shield is protecting the person who is wearing them. This is the chin strap piece. Although it does have circles here, it is not designed to have holes punched in it. It fits right in here to help it take the shape a little bit more around the person who is wearing it. And again, it can be removed or put on for comfort purposes. Here's an example of the shield with the chin piece on. So when I turn it around, and you can see how it fits inside here. There's a very thin channel for the plastic to go in. These little rivets here hold it in place. It does not need to be 3-hole punched in any way, shape, or form. It just helps it fit more snugly on the bottom. And again, that piece can be adjusted based on the person who is wearing it and their comfort level.